example of, again, simplifying things with cofunctions without knowing a concrete angle. We're just given some information about one of its trig ratios, in this case, sine. So given sine of theta equals 1/4. So I have to consider all possible places where sine of theta could be 1/4, since I don't know exactly what theta is. And so since it's positive, I know 1:4 ratio could exist here. But also, since sine depends on the y value, well, that's a horrible straight line. It could be 1/4 here. So I've got two quadrantal values, two quadrants, I should say, that I should worry about. And in one of them, this would be the square root of 16 minus 1, so root 15. And on this side, it'd be negative root 15. So, oops, except for that looks like an 18. Let me fix that for you. So again, depending on what I'm being asked, I might have a plus or a minus to deal with. And I have, again, two representations of theta. Here's theta in quadrant 1. Here's theta in quadrant 2. And the way I denote it in quadrant 2 is the fact that I have a negative root 15 there. Okay? So thinking about the process, we want to write in terms of theta, look at the behavior, and then evaluate. So I need to write this in terms of theta. So cosine of 180 minus theta. So let's draw what that looks like, because it's bigger than 90. So you go over 180 and you backtrack theta. So we're sitting right here, and that means if this angle, again, this angle here is 180 minus theta, right? That means its reference angle, which is right here. Oops, I thought I picked red. Or this orange. This angle right here is actually just theta. So I can represent this as a quadrant 2 angle with theta, but I've got to concentrate on the behavior. In quadrant 2, cosine is negative, so it's negative cosine of theta. So now I've got that. So I go up to this first quadrant, and the cosine here is root 15 over 4. The cosine here is negative root 15 over 4. So it's the opposite of plus or minus root 15 over 4. And again, whether you leave it as plus minus or you do the flip to make it minus plus, it's up to you. It depends on how cool you want to be. I'm just kidding. But like that indicates you to the opposite of the plus minus. Okay, next example, tangent of 90 plus theta. So again, I'm sitting at a triangle that's more than 90 degrees, because there's 90 and I go theta past. So here's my angle, and again, the plus theta meaning the theta's out here. There's theta, which means the reference angle, if I were to drop my triangle and look right there, that reference angle must be 90 minus theta. And so then I can rewrite this as a tangent of an acute angle, so 90 minus theta, but the behavior of tangent is negative in quadrant 2. So then I hold on to that negative, rewrite this to be cotangent of theta, and look at my quadrant. Up here in the first quadrant, cotangent is root 15 to 1, and here it's negative root 15 to 1. So that means I have the opposite of plus or minus root 15 to 1, which is root 15. So it's the minus plus of root 15. Okay, and at any point, feel free to stop the video and try one on your own, and then come back and check. Okay, so 270 minus theta. So we will draw this. I don't think we've done one like this yet. So 270 takes us all the way to the South Pole, and you backtrack theta. So you draw your angle sitting here in quadrant 3, but since you backtracked theta, that means that its reference angle sitting right there is actually 90 minus theta is the reference. So we're going to rewrite this as an acute angle, cosecant of 90 minus theta is reference, but that angle of 90 minus theta is in quadrant 3. Cosecant behaves negatively because it depends on the y value. And now I hold on to the negative, rewrite cosecant of 90 minus theta as secant of theta, and then I go back and check my picture. Secant of theta in quadrant 1 would have been 4 over root 15. Secant is quadrant 2 is 4 over negative root 15. So we have the opposite of plus or minus 4 over root 15, which is minus plus. And if you leave it as 4 over root 15, I'm not going to mark it wrong. but if you remember to simplify minus plus, 4 root 15 to 15. Okay, secant of theta minus 90. Again, another one we haven't seen in a while. So if I think about drawing, if you go up theta, right? So let's say that's theta, and then you go back 90. So you turn around and go back 90 degrees, which means that you've got a right angle here. And if the upper part is theta, that means when I draw its reference angle, it's going to be 90 minus theta. In this triangle right here, that reference angle is 90 minus theta. So let's think about rewriting this as a acute angle. It's secant in quadrant 4. The behavior of secant depends on the x, so that stays positive. So I don't have to adjust a negative. And rewrite this as cosecant of theta. Look at your picture up here. Cosecant in this quadrant would be 4 to 1. In this quadrant is also 4 to 1. So it's just one answer, 4. So that's very nice. Okay, 180 plus theta. We may have done this one, I don't know. But let's go ahead and draw 180 plus theta. That's going to put us into quadrant 3. So there's the big angle, 180 plus theta. This one might be a little more obvious what the reference angle is, because when you drop your triangle and create that right angle right there, that reference angle happens to be theta. So we can write this as an acute value and an expression of theta. But remember, in quadrant 3, sign is negative. And then we go back up and look at our picture. And in each of them, sign was 1/4, 1/4. So we just get the opposite of 1/4 and just get one answer. Okay, I think our last one here, yeah, so theta plus 270. So again, draw the picture, right? Where does that going to take you? That's going to take you at least to the South Pole, right? Because that's the 270, and go theta more. So there's our triangle, there's our angle. And again, theta is on the outside, which means when I draw its reference, this angle right here is 90 minus theta. So I can rewrite it as an acute expression, 90 minus theta. It's the cotangent function, but the behavior of a quadrant 4 cotangent is negative. So then once I've written that, I can say that's going to be negative tangent of theta and go back up to what, to evaluate tangent. Opposite over adjacent. One of them is going to be 1 over root 15. This one will be 1 over negative root 15. So we have the opposite of plus or minus 1 over root 15. And again, be cool like me, right? Minus plus 1 over root 15, which is equal to minus plus root 15 over 15. Okay. So the thing about these problems, if you're feeling a little, I don't know if overwhelmed is the right word, but there's a lot to worry about. It can be easily confusing because there's not a lot of work. It's a lot of thinking, right? So take your time, try some examples, look through the solutions, come and ask me questions. But again, thinking about key things, draw your triangle, especially if it's greater than 90. Write it as, and maybe instead of saying as theta, maybe I say write it as an acute angle. I'm going to maybe adjust that a bit. Write that as an acute angle, because the first couple of examples, I think they were already like acute. So I just said theta. Write as an acute. And I'm writing this sideways, so I apologize for how messy it is. Look at both quadrants, account for the positive and negative behavior of the function for the angles that are greater than 90. So that means if you transition out of those quadrants, is the behavior of that function negative? Okay. Like I said, come see me if questions. Otherwise, try some more examples and hopefully they go okay for you.